Video. Start times. See, I want to change this.
So today, what you are doing, Chandu? What topics you are covering?
Let's cover the let's do the RI dynamic routing protocol.
What protocols?
Dynamic routing protocol.
Oh, okay.
RI.
So these topics come into which, like leaf, spine, architecture.
No, the leaf and the spine.
Mhm.
They are the architectures of the in the data center that we use.
We will have an overview on that.
Yeah, we'll do.
Okay. Thank you.
So we take a one router and one branch having some permissions. Have a router two having a switch with two devices again. We take the router 3. Here we have a switch and we have some more devices in that. And today I want to take the redundancy connection also. We also can start recording the meeting. So I'm going to connect the pieces to the switch. Connecting PC to the switch. And we are going to connect your router Giga 0 to the switch. And also we are connecting the router to the switch. Also router to the switch. We need to add the minimum 2 serial cards. Adding the serial cards. Also drag and drop the serials. Again, power of drag and drop the serial. So then we need to connect the router 1, connecting serial 0 1 by 0 to router 2 serial 0 1 by 0 and router 2 serial 0 2 by 0 connecting to 0 2 by 0. So I'm not getting the router interface names. Click options, preferences, click on other show port table. So also let me take the redundancy connection between from router 1 to router 3, that is serial 0111, serial 0111. So we have some two LAN connections and one LAN connection. Two LAN connections and two LAN connections. So let me assign for the Giga 00, it is 192.1.1.254. 191 set 2.254, and the router 3 I'll give 192.168 3.25. Serial 0 1 by 0 11.001, and I give 11.002 normal play. I give 12.001 12.002, and it is 12.001. 13.001, 13, 0, 13.003, also 3. So we need to configure the interfaces. So meantime, if you have the Rafik number, please call him and ask whether he is running or not. So because it knows, you need to configure all these interfaces first. Enable config D interface, figure 0 by 0 by 0, and define IP address, which is 192.168.1.254, 55.255.255.0, and define no shutdown. The interface serial 0 by 1 by 0, which is connected to the router 2, and its IP address should be 11.0.0.1 to 55.0.0.0, and define no shutdown. And of course, yes, sir, we need to define encapsulation
HDLC.
DLC, then clock rate 64,000. Then again, I have interface serial 0/1/1 connected to router 3, and its IP address is 13.0.0.1 to 55.0.0.0, and define no shutdown. Encapsulation DLC again, find the clock rate 64,000. Then make this host name as R1. And for these computers, we'll give also current on set 1.1, and this is 191.168.1.2. Current on set 2.1, current on 191.168, 2.2. Current on set 3.1, current on set 3.2. Just we need to assign here this interfaces here for the computers also. 191.1.1, 191.1.255, 191.1.2, 191.1.2. I'll try to save this lab. Hereafter, no need to configure the interfaces because I'm losing the time. We are losing the time. Okay. Save the lab. Connect on state 2.1. Connect on state 2.2. Return set 2.2. Return set 2.254. This one should be 192. Set 3.1. Return set 3.254. And this should be 3.2. So we need to configure outer 2 also. I'm waiting for CLI. Host name is R2. Interface 0.0/0/0. IP address is 192.168.2.254. Interface serial 0/0/1/0. 1/0 is connected to router 1. The IP address should be 11.0.0.2. And you define IP address as 11.0.0.2 to 5.5.0.0.0. So shut off encapsulation. Yes, fine. Put it block it here. Interface serial 0/2/0. Interface serial 0/2/0 is connected to router 3. Whose IP address should be 12.0.0.2. IP address is 12.0.0.2 to 5.5.0.0.0. Shut down encapsulation. DLC. Find the block rate. Enable completely. Host name R3. Interface figure 0/0/0. IP address is 192.168.254. 255.0 no shut down. Interface serial 0/2/0 connected to router 2. The IP address should be 12.0.0.3. Yes or no, Abdul? You're following, yes?
Yes, yes, Chandu. Yes. The serial one is like I'm just looking at that
Our
because
serial M1, the router 3 serial 02/0 here. 12.0.0.3 is actually there. 02/0. So it is connected to router 2. The address is 12.0.0.3. 12.0.3. 5.5.0.0.0. And we define no shut off. Calculation serial okay. Interface serial 0111. Let's see that is 0111. IP address is 13.0.0.3 to 5.5.0.0.0. Push it down. Calculation is CLC. Find the clock rate versus traffic time. Because clock rate command always will be applied only on DC, not on DD. So if you want to verify whether which type of serial has been connected, find show controller here 0/1/1. You type the command show controller serial 0111. So the interface is serial 0111. It's connected to DD. So on the DD, will not accept the clock rate.
yeah. Can you repeat this show controllers?
Yeah. That is how we want to know the hardware of the information of the interface. When you type show controller serial 0111, you can enter the command here. So when you type show controller serial 01/0, the serial 00 or 02/0 or anything, the interface name, hardware is forward, and it's connected with the TDA and clocks detected. All these are the other drivers information. buffer size. And later classes I will tell you also how to change the bandwidth parameters and all that. So if you give like a show controller, here serial 0111 for example. What is the command I give? Show controller serial 011 also is there. 02 by 0 is there. Let me give show controller serial 01 by 0. When I give this command, no serial cable is connected, attached. Of course, yes, we connected only 02 by 0, 0111.
If you give me some time, like 2-3 minutes, I'll just check in my live environment. One
You can
moment.
check
Yeah, in the end. Yeah, in the after the class. Yeah.
okay. You can attend for one session for this, Abdul, because anyway Rafiq didn't come.
Okay.
And later again tomorrow also. From tomorrow will not miss any class. Okay.
Yeah, yeah. Because the problem is in the weekend I am busy sometimes because my family time. It is
I
my
do.
family time.
For me, it's very because two
But
classes
we'll
just
we'll manage anyhow. Okay, no problem. Sometimes emergency arises, so weekly at least 3 classes should work out for me.
no 3. You have to reach at least 5.
Pardon?
5 every day class, na?
Yeah, yeah. No, no. I'm saying like in case of emergency also, like at least 3 or 4 will also work out for me. I have no problem.
So in today's class, we are going for the routing protocol, the RIP. Actually, the RIP has been outdated from ccna syllabus, but you should know it. It's very important.
So for CCNA, you don't have questions on RIP?
No, no questions on RIP.
Oh, okay.
But when you do CCNP level exams, CCIE, you'll get some RIP routes will be injected to get the
Okay.
loops. They'll ask us to how to just troubleshooting the things.
Okay. If I target CCNA, I can finish off CCNA. I can pass out CCNA in June ending. You think?
You want to? We can start as soon as possible. Also,
Okay.
we need to wait until June. Can start soon.
Okay.
Once you complete our class, I give you. You have to register yourself on some websites to download to prepare for the dams.
Okay.
Prepare the dams and prepare for the exam.
Okay.
So RIP stands for Routing Information Protocol. But this blur is coming. So RIP. So RIP stands for ccna Routing Information Protocol. Routing Information Protocol. RIP is a first point. RIP is a IGP. An IGP, a dynamic distance vector. RIP, it is a IGP, the distance vector dynamic routing protocol. RIP uses Bellman-Ford algorithm. Bellman-Ford algorithm. I'll explain all this at some points. RIP provides smooth routing table information particularly for every 30 seconds. Okay. So when you're going for a RIP is an IGP, a distance vector dynamic routing protocol. In your last classes, you learn about the routing concept. Routing is in a process of sending the packet from the source to destination by selecting best path. Ravi and Sai, no, you should ask me also if you have any doubts.
Okay, sir.
So, remember last classes we learned static routing and default routing. Actually, when you say like a routing, I said routing is a process of a process of sending the packet to the destination, selecting best path. Yes, selecting the best path. Always the routers will select the best path to reach the destination. And routing is categorized into three types. Routing is categorized into three types. You said like a static routing, and again we have a dynamic routing, and again we have a default routing. And also we discussed like the static route is configured only for known destination, and the default route is configured for unknown destination. But furthermore, the dynamic routing protocols actually they are divided into two types. Okay, one is called as IGP, interior gateway protocol. Another one is EGP, which is exterior gateway protocol. The IGP routing protocols are again separated into two types, based on their functionality, based on their working process, and based on the algorithms that what they use us. They're divided into IGP as well as EGP. Again, IGP are again of two types. We have a 1 minute. Oh, Pranay. Join the 1 minute. One is as distance vector. Distance vector. The other one is the link state. So the distance vectors are RIP first. Also we have IGR. Again we have a EHR. In the link state protocols we have OSPF and we have ISIS. The BGP is also known as path vector. Path vector. In the path vector it is. In the path vector routing protocol we have only one, that is BGP. Okay. So RIP, routing information protocol, it's a distance vector IGP dynamic routing protocol. It falls back under the distance vector, because always the distance vector counts something called like hops and something called like a bandwidth. The distance will be they count the distances to select the best path. Whereas OSPF is going to select the best path based on the link states. Has the link is a physical connection and the state is its description to the neighbor. Now I will not discuss on the link state. Let's concentrate only on the distance vector only. So I want you to know that the RIP falls back under the distance factor, IGP, dynamic routing protocol. So IGP uses a Bell-Manford algorithm by default. Like for example, we have A plus B whole square, A square plus B square plus 2AB. Huh? Every routing protocol, they have their own algorithms as well. So I have a router 1, I have a router 2. Let's take only 2 routers. Of course, this router 1 and router 2 are connected. Let me save this lab. In the case if power goes, you don't want to configure anything. Let me write the, I'm saying the like in the configuration. Then I want to save this. On the desktop, the file name as fine. So consider teacher, I have a router 1 with your R1 and this is a router 2. Of course, they have the WAN connection. In the router 1, take for example, I have 10.0.0.1, 10.0.1.1. In subnetting class, I will tell you. Take for example, I have 2.1. Hello Pranay. Hello Pranay.
Yes. Hello. Sir, can you hear me?
You log
Hel-
in to mobile.
No, sir. Laptop.
Okay. You can start recording also. Already attended this class, you know.
Yes, yes.
So 2 dot. Say for example, I have like some networks are there. Oh, you think sorry, all this belongs to the class A. But I say slash 24. They have been submitted. And submitting class, I will tell you in tomorrow class for you. Take for example, router 1 has some these networks. Router 1 has these networks. Router 2 consider also has some network. For example, 11.0.0.1 and 11.0.1.1, 11.0.2.1 slash 24. You know, when you say like slash 24, the octets will be the network. So these are the 3 different networks will be there. Router 1, when you configure it, or whenever you configure the dynamic routing protocols like RIP, OSPF or BGP, what they do is they do something called advertisement. The dynamic routing protocol, what they do is they do something called advertising. What do you mean by advertising? For example, long back you come to Hyderabad. Now you don't know a place name called as, for example, some place name you don't know. So if you want to go to that place name, or when you are traveling, maybe you want to see a Walmart in Hyderabad, or there is a Walmart. So you take a car, you try to travel, and when you are passing from Torichoki to Gachibowli side, on the left side you find there is a board Walmart. So you see the board name Walmart, then you understand that there is a Walmart there. So why that shop people, everybody they keep the boards in front of their place, like KFC, McDonald, or the jewelry, Walmart, and so on, because they are advertising themselves to the public. When you configure the dynamic routing protocol, the routing protocols, what they do, the router 1, is going to advertise its full routing table information to the neighbor automatically. Router 1 will advertise these routes to router 2, and router 2 will advertise all these networks to router 1. Means they are going to share their information. They are sharing the routes. So RIP is going to advertise its full routing table information periodically for every 30 seconds. So router 1 has 1, 2, 3. First it has 1, 2, 3. 1, 2, 3. Now say for example router 2 has a B, C information, the routes. So what router 1 will do? He will share. It's going to share his information to router 2. So router 2 writes this information in 1, 2, 3 in its routing table. And what router 2 will do? Router 2 will share his information. I cannot use the word now sharing. Router 2 will advertise his routes information to router 1, and router 1 writes his information. Now what router 1 will do again? Router 1 after every 30 seconds is going to share its full routing table information. So router 1 again it shares all the complete information from router 1 to router 2. Router 2 will write it checks its database. If any modifications are there, that router information should be written in its database again. Again, router 2 periodically for every 30 seconds they are advertising with each other. Comparing with static and the default. For static routing, for every network I have to make a route. So it will be very big difficult in a big enterprise network where you have router 2 has so many routes in its LAN. Later classes will LAN, and the router 2 will be having a switch. You will be having like so many VLANs, every VLAN in different network. So for every network to make a static route, it's very difficult. That's why they prefer the dynamic routing protocols in a big enterprise network. But can you tell me what could be the disadvantage in the RIP now? Well, RIP is going to advertise its full routing table information critically for every 30 seconds. Actually, if there is no changes in the table, still the routers they advertise their information. So it causes utilizing of memory bandwidth, processor bandwidth, unnecessary advertisement sometimes causes loops. So it's doing like critically for every 30 seconds. So these theoretical updates are not there in the case of EHRP and OSPF. They do something called incremental updates. EHRP, OSPF, BGP, they do incremental updates. Incremental means what changes are done only, those will be advertised. So maximum hops that the RIP supports. The maximum hops that the RIP is supporting is 15. So the 16th hop is unreachable. So in a path, the maximum that the RIP supports only 15 hops only. So the 16th hop will be unreachable, or it is going to poison the route from the routing table. And RIP will calculate the best path based on the least hop. Least hop is the best to reach the destination. And shortcut actually we call, what is the metric for RIP? We say least hop. Your interview, they use this word called metric. So what is the metric? Calculating the best path. So RIP is going to calculate the best path based on the least hop. Least hop is the best. Oh, sir, what do you mean by least hop now? Just give me 1 minute. If, for example, this is A, B, and C, D, E, F, G, H. So every network, they have their own LAN. So LAN, and they have a LAN. Take, for example, router A is connected to the B, A is connected to the D, A is connected to the F. A router which is directly connected becomes as a neighbor. Okay. So router A is connected to the B, A is connected to the B. So B is a one neighbor. D is also connected. D is also a neighbor for A. F is connected to the A. F is also become a neighbor for router A. So router A has three neighbors. Always in the dynamic routing protocols, whenever a router is connected, directly connected, assumes that it's a neighbor. Now, okay, it's a topology like this. Router G, how many neighbors it has? Tell me, router G, the router G, how many neighbors it has?
Two.
Hmm?
Two.
Two. What they are?
F
And
Yeah.
F and
G.
H.
H.
So,
The router G is connected to the F
yes,
and
yes.
H. This two becomes a neighbor. The
Okay.
router G is connected with C and also is connected with D. The router G, how many neighbors it has?
Four. Four.
D, E, H.
E. Yes.
Okay. I don't want to confuse you. Now just concentrate on this. To reach from router A to router C, always to reach from router A to router C, there are always the RIP is going to maintain something called path. The least path is the best to reach the destination. So to reach from router A to router C, now if there are some three paths are there. One is means see I have a user here. Understand he has a computer, it's connected to the switch, and also router C also has a LAN connected to the he has a computer now. So this user wants send the data to this user. Once the traffic is coming on the ingress interface, where the packets are coming inside, is called ingress. And when it is going out, it is called egress. Ingress and egress. Ingress and egress. Ingress and egress. So always in the always in the ingress interface, the packets are coming inside. The egress interface, the packets are going out. So the router A is going to calculate something called as hops, and on the first path we have A, B, C. It's a one path. So ABC is a one path. ABC. Another one is A sending to the data to the D, A, C. There is A, D, E, C. Another one is AF, GH, AF, GH. Now take for example, if I connect a one more WAN connection like this, A will have ADEC and also AF, G, E, C also. Okay. Now I don't have like this. I have connection like that. Now can you tell me how many paths are there? How many total paths are there to reach from router A to router C? How many paths are there?
4.
Tell me, louder. I want also to know who is saying.
4. 4. 4.
Four only.
Yes.
Okay, can you tell me the fourth path?
A, F, G,
G,
D, D,
EC.
EC. Yeah.
And don't have another any path?
Yeah.
There
We
is
have
another path ADGHC.
ADC. Yeah.
Then say the fifth one can be A,
D,
B,
G,
D.
H,
Yes.
C.
Now, there are totally 5 paths are there. Yes. So in this case, RIP is going to calculate always the least hop is the best to reach the least hop is the best to reach the destination. So among the first path, B is connected one hop and also C. So in the first, there are only 2. In the second one, DEC, there are 3. AFGHC, F is a hop, G2, H3, C4. So there are 4 hops. Now in the fifth path, A connected to the F, G second, again D, 3, 4, 5. And here also AD, D is one hop, 1, 2, 3, and 4. There are 4 hops are there. So among these, all this, which is our least hop? Number 2. So the 2
ABC.
become as the best to reach the destination. Okay. Now, RIP is not going to calculate something called bandwidth. The bandwidth is not going to calculate, no. Just to calculate this least hop as the best to reach the destination. Now I'm saying there is a issue between A and B WAN connections. This network is down. Can this router A can reach router B?
Yes.
Can
Yes.
router A can reach router B?
Yes. Yes. But the path will be very too high.
The hops are high. That's but no problem. The protocol will calculate that hops again.
Okay.
So one is router A can reach to the router B LAN. Hops are D 1 hop, E, C 3 plus 1 4. 4 hops in one. Another one is AF 1 1 2 3 4 5. There are 5 hops. Another one is D 1 G 2 3 4 5. Again 5 hops. Again F 1 2 3 4 5 6. So there are 4 paths are there. One path is down. Altogether, every router will maintain 5 paths actually. If one path is down, among the remaining path, one is 4, 5, 5, 6. Which is the least? 4. Now the fourth one may be, take for example, in this case, this is down. This is down. Again. Can router A can reach router B again? Yes. One is 1, 2, 3, 4, 5. Again 1, 2, 3, 4, 5. So there are 5 hops are there. When hops are same, it does something called as equal cost load balancing. Means both paths will be utilized. Both paths will be utilized. So don't want to go for big. This is a big topology actually for you to understand. Actually, take for example, I have a router 1, I have a router 2, 3, and 4. Yes, that's it. Now they are being connected together. Now, when you configure RIP here to reach from router A to router C, there are 2 paths. 1, 2, 2 hops. 1 is a hop for A. 1, 2, 2 hops. Hops are same. Then the router, when the hops are same, both paths it will be utilized. And on 2 paths, it will send and receive the data as well.
Do we have any maximum number of routers to use in RIP?
Maximum hops that the RIP is supporting 50. So the 16th hop is unreachable. In one path, Ravi, it supports maximum only 15 hops only.
So to have 15 hops, do we have any like maximum number of routers, or is it?
The path will calculate in every path. It will calculate the maximum hop. In every path is going to calculate the hops. So maximum hops is 15 is supported. Like for example, I have one branch. They have been connected like point to point, 1 to 1, 1, 2, 3, 4, 5, 6, 7, like this. So router 1, this is becoming one hop. 1, 2, 3, jump at. Router, this is B is a hop, C also, D also, E, F, G, H. 1, 2, 3, 4, 5, 6, 7. Like this, if you are going, 15 you can connect. 15, all routers information it can maintain. But the 16 hop will be unreachable.
Can you show on like trace route? Google.com, yeah.
Yeah. So that. So the AJRP is the RFP is going to calculate the best path based on the least hops. The administrative distance that the RFP supports, or we can say RFP routes as the administrative distance. Administrative distance for the RFP is 120. RIP routes will have the distance of 120 as well. And we have like an RIP has some versions. We have RIP version 1. We have RIP version 2. And again we have RIP NG, next generation. So RIP version 1 always does something called like an broadcasting the routes by using the IP address 225, 225, 225. But whereas RIP version 2 does not do broadcasting, instead it does something called multicasting. MULTI, multicasting the routes using the IP address of 224.0.0.9. Always RIP version 1 is older one, of course, yes, it's modified to RIP version 2. So in the RIP version 2, always they do something called multicasting the packets. Of course, yes, AHRP and OSP of ISIS, they do the multicasting. Only the PGP is an unicast routing protocol. So RIP version 1 does like broadcasting the routes, and RIP version 1 it does not support authentication. And also does not support summarization. But whereas if RIP version 1 is not supporting, RIP version do support that. Okay. RIP version 1, RIP version 2, or RIP NG. There are 3. So RIP version 2 support authentication. And also RIP version 2 do support the summarization. For example. And RIP NG is used for IPv6. Next generation used for IP version 6 as well. Now what do you mean by authentication? For example, I have a router 1, router 2. Of course, the router 1 and router 2 are connected by using WAN connection. So this WAN port, WAN connection, I want harden it. I want secure a lot. So you can define something called like any key string called password. So I give like a key string, like in Cisco, at the rate 123. And on the same router side also, need to define the key string Cisco at the rate 123. Mismatch of the key string, they will not advertise the network. A mismatch of the key string, they does not make the neighbors as well. You can give any string. String is a password. మన Gmail key, sorry, you use a password for the Gmail, or you have a password for Facebook. You have a key for your bank account. So that should be matching on both ends. Like if it is matching or mismatch means, or even if you configured in router 1, if you don't configure router 2, in router 1 you configure the key string. In router 2 you have not configured the key string. Router 1 assumes it does not have a key, so they lost the neighbor. Once key is saying, then they update the router information. Because in older days, when your routers are using some older version, there are hackers on the internet. They try to do attack on the router itself, not in your LAN, not only in the LAN, but the devices are also, if they are compromised, if he injected a false route to his network, all your company data he can capture it. It was happened so. There are like so many routers networks are being compromised. The network devices are compromised means it's very difficult for the network engineer who is working in that. So in order not to compromise the network, you configure authentication, very secured one, and something called summarization. The router 2 has directly, it is connected with some routers, okay, and they have around some 100 networks are there, 100 routes are there. What router 2 will do? It will advertise all the 100 routes to router 1. Okay, it will advertise all the 100 routes to router 1. So instead of maintaining 100 routes in the router 1, the router 2 can summarize all the 100 routes as a single route. Summarization is in a process of combining multiple individual routes as in a large subnet. Like one, you know, in your high schools, they'll give you a big paragraph of notes. There's a big story they'll give you, and they'll ask you summarize into 100 lines or summarize into 100 words. The student who summarizes them in a good way, he gets a good mark. There is a summarization. Here also same. You can summarize the routes to reduce the routing table, to reduce the again memory utilization, processor utilization, because the end station routers. Okay, I have one branch connecting another branch. So this branch does not have, it's a very older device, does not have a RAM, memory is very less. So to maintain in this router, managing some 100 routes is very difficult. Like for example, the routers of 1700 series. It's its memory is very weak. Routing will be very slow. So to manage 100 routes, I'm saying, or managing 1000 routes. So what we can do instead of this, we can summarize them as a one. So those things are not supported in the case of version 1. Version 2 support authentication and summarization. So coming to our lab, let's see how to configure the rig. I go to the router 1. I'm going for configuration mode. Enable config router RIP router rig, and I need to define the version VRSIYR version 2. Router rig version 2. Then network. What network I have? 11.0.0.0. Again network I have 13.0.0.0. Again, my LAN network, I have 192.168.1.0. You see, if I give subnet mask, you get error. There no. I'm giving you error before you LAN. How to give the router A version 2 network ID over the. You have to use classful network again. Then there is a command called no auto summary. No auto summary. I don't want to summarize to the default classes actually. Actually, the routing protocol will summarize to the default classful network. We'll have some issues that we'll discuss in the case of summarization when you do it in the OSPF. So it's better for best practices in order to overcome the loops. In order to we give the command no auto summary. Router is portion to network IDs. This is in the case of router 1. We're going for router 2 now. To configure RIP, have to go to area boot, configuration mode, router RIP. If I don't define the version 2, it takes version 1. So it must define version 2. Then after this what? What network router to contain, he has to advertise in the protocol. The command called as network. And you need to define the network ID. What router to contain? The serial network 11.00.12.0.0.0. The network ID is 11.0.0.2 is IP address. But what is connected network ID is 11.0.0.0.
00.
Again, network is 12.0.0.0.
Dot 00.
Again, network is
192.
168.
Dot 2.0.
Network spelling double RK. Then I need to define so auto hyphen rescue LMARY. Sorry. Then let's see. How to do it? Configure the things and check how they are working.
Excuse me, Chandra, what is this no auto summary?
Yeah. No auto summary. Take for example, I have one headquarter. I have like so many branches are there. I have so many branches are connected with headquarter now. Of course, headquarters connected with maybe branch or I have some other branches in other country. But these are the routers which are connected in the in one location. Take for example router 1, because to understand summarization, you need to know about subnetting. 10.0.0.0/network is this. 10.0.1.0/24. 10.0.2.0/24. Consider here there are 4 networks are there. Or 3 networks are here. In router 2, from the same class 10. Say for example 10.0.100.0/24 is a one more network from class A, but all these are the different networks now. /24 means subnet must be 255.255.255.0. Tomorrow class I'll tell you on Monday. Subnetting will teach you on Monday.
Okay.
10.0.101.0/24 again. This is another network again. 10.1.102./24. If you don't define no auto summary, this router will summarize all these routes to a classful network. Classful means 10.0.0.0/8. This router 2 also will summarize the router 2, something called auto summarization. This router 2 also will summarize to its classical network, which is 10.0.0/8. Now from branch, if somebody is trying to come to reach a network of 10.0, he is trying to ping and he wants to access the data of 10.1.102.1, for example. Since these routers are injected to a default classical route, whenever the packet is coming to reach 10.1.102, it sees the network of 10. So wherever the 10 networks are there, it is going to forward the packet. So it will forwards the packet here. But here we have 10.1.102.0. There is a one more route means one more branch is there. So this network is this. So you have to reach exactly to this, but it's going to all the other networks here also. So I'm saying if you don't do summary, if you don't give no auto summary means I don't want to summarize to the classical network as well. Then they will not advertise. The individual routes will be advertised to the headquarter. So the headquarter now knows to reach 10.1.102 network, it should forward to this particular branch. So it will forward to him only. It will not forward to other branch.
Okay, got it. So it's a kind of security hardening, right?
Yeah, it's the security. I don't want to drop the packets. I don't want to send the packets to the default network only. Unnecessarily broadcasting of the packet will not happen when you configure no auto summary. So in the router 2 also, I think we have done RIP. Now you tell me in router 3 how I have to do. Tomorrow class I'll give you, next class I'll share my screen. I'll give the access of my computer access. So tell me in router 3 how I configure RIP. Everybody, I'm asking everybody, not one. Pranay,
Router
go to configuration report.
Configuration.
configuration mode. Router
Router RIP, yes.
version
Version
Version,
2.
2.
can I give version 100?
No.
Fine, version, give version mark.
Yeah. Version
Only one for there. Version 2.
we need to give network
Network
12.0.0.0.
0.
Okay.
And we have another one. Can you?
12 is all, that's it.
Yes, sir.
Antena?
Another one, network 13.
13.0.0.
13.0.0.0. Now, by mistake, if I forgot not to give LAN, router 1, router 2 can ping only to their networks only until this one. They cannot reach this network.
Okay.
And if you give wrong route, for example, I don't have a network, for example, 192.168.4.0. Do you have a 4.0 here? You don't have a 4.0. No, nobody is 4.0. It is 3.0. So even if you give wrong network which does not have, it will not advertise. You will not have 4.0 here because the 4.0 is not connected. So the connected network only you have to give. Remember what do you mean by connected network?
Okay.
We did this. To show IP interface brief. To show IP route, for example. What are the connected? Is connected. I have to advertise 12. I have to advertise 30. I have to advertise 9168. 3.0 also connected. It's a network. Automatically, since we advertise the serial, he is able to receive the network. You see 1.0, 2.0 key. So network is 192.168. 3.0.
Zero.
Then you need to define the auto summary. Okay. Basics, all these are very important. You have to do this. If you don't do this, we cannot go for big other classes. Yeah. This is the how you configure router 1, router 2, and router 3. So then now the verification command, look in the router 1, if you give the command and show IP route. Show IP route, so I'm checking the routing table information. So I'm getting 192.2.0, 191.3.0, and also 12.0.0.0. To reach 191.2.0, that is router to LAN. 120 is the administrative distances, and this is the hop, which is directly connected. And 11.0.0.2, you see here. Router 1 needs to send the data to this 191.2.1. So there are two paths. One is via this way, another one is via router 3 to 2 to 1. There are two ways. The two paths are there. This computer needs to communicate with this. Once the packets are coming up to the router and the ingress interface of the Giga 000, it's going to send via this two path, but it will select the best. But via this way, 1 plus 2, two hops are here. Via this way, one hop, directly connect to one hop. This will choose as the best. That's why you're getting 11.0.0.2. See there. You're getting 11.0.0.2 actually. See, this the hop is there. The first router to reach 191.2.0 via 11.0.0.2. Send the data on the serial 0.1.0. Now, what about this router 3? If 191.1.1 is to communicate with 3.1, there is a one direct path, one hop. Above one is 1 plus 2, 1 plus 1. There are two hops are there. Same, is going to select the least hop, which is 13.0.0.3. To reach 191.3.0, see 13.0.0.3. I'll give you the hop. Let me tell you. So when you configure, after configuring the rate, always you give the command right here out, verify the routes information, if they are getting or not. Then you try to ping. I go to the PC. I'm trying to ping to 192.168.3.1. Yes, I'm getting a reply. And also you can trace RT 192.168.3.1. So sending data to my router 192.1.254, going to 13.0.0.3, going to 3.1 PC. Now, what I do, this is serial 0111. I go to manually, I go to config interface serial 0/1/1. But before going for this, let me just count here. Router 1 to reach 192.1.3.0 network, how many hops are there? 1. Only 1. But that particular serial, I am giving shutdown. The interface 1 shutdown. In the meantime, if I type the command show IP route, you may not have 191.3.0 now. Take some time duration of 180 seconds to get router 3 information. Now you see it again. Because the router maintains the information of 3. Now you got it. Now I can reach 191.3.0 via 11.0.0.2. But the hops are coming to, the second hop came. The best path is lost. Once the best path is lost, if it has a backup path, it chooses that as the backup path as the best to reach the destination. Now, if I'm trying to do the trace route command, say, I will not have 13003. Now see here. This path is down. This path is gone. Some maintenance work is going on. So they said manually you shut down. So if router 1 wants then data with router 3.1, it goes to the PC 11.0.0.2, 12.0.0.3, then 13.0.0.1. That's why you have two hops. 11.0.0.2, 13.0.0.3 are the hops. If you trace to again 3.1, see, it's going for 11.0.0.2, 12.0.0.3. If my best path comes up again, 150, interface serial 0/1/1, if I give this down, okay, the interface comes up, some maintenance work is gone, done. And if I give the command show IP route, fill the hops, you see, interface instant comes up now. Now the best path is being present in its web database, routing table information. Then it will choose 13.0.0.3 is the best. Means the path comes again, it will choose this is the best again. Means this path will be used again. It will not use the second hops path. Since how RIP is going to work. RIP will calculate always the hops. So the least hop is the best to reach the destination. 120 is the administrative distance. That's the distance for RIP routes. I can go to config T. Furthermore, yeah, type the command show IP protocols. So the protocol that I configured is RIP is going to update every 30 seconds, actually sending updates for every 30 seconds. Next schedule 23 seconds. So after 23 seconds only, now I have given show IP protocol. Next schedule 5 seconds. So within 5 seconds, if any changes are done, then it is going to be updated. Hold time is 180 seconds, and also invalid after 180 seconds, and flushed after 240. So 240 seconds, if I don't receive any updates from the neighbor, okay, it is going to flush the routes information from the neighbor which is advertised from its database table. So database table, you check the command show show IP or IP database. This is a RIP database. And from the database, what is the best will be there in the routing table. Show IP route command, the execute. Okay. Oh, what is time now? 9:26.
9:26.
Why my time is 9 p.m. Oh my god. I didn't change. No, yesterday, 2 days back, I formatted my PC. Get to the PC now. Anyway, so what I have to do? Yeah, if you are going for if you are going for a few more seconds, go to configure authentication. Now you we are connected to the internet. It may not be secured, yes. So here we define something called like keychain. You go for the router 2. Router 2. Go to enable config p hyphen chain. Keychain. Keychain. Name Cisco, for example. And key 1. It's going to generate what we can do in keychain. Question mark. There is a key and exit. No, negate, no. So you define the key 1. So in the key 1, you define password that is called key string. Key hyphen string. STRING, yeah. Key string. What password I want to give? Chandu 123, for example. That's it. Then 10. I'll give you wait. Copy. Keychain Cisco, and you'll be in the keychain as well. Which define key 1. When you're on the keys, you're in the keys. The key you define key string, the password. Then I need to configure it on my interfaces. An interface that you are connected, you apply the keychain. My serial is 0, 1 by 0, yeah. So I go to config again. Sorry, config interface serial 0 by 1 by 0. Go to the interface serial 0, 1 by 0. So configure the authentication. I am sure that it's IP RIP authentication command. Maybe, sorry. I could raise it uses. Because this factories will not give all. IP before RIP authentication. Yeah, if I change, then what to do? There's a problem with the back tracer. Sure, we are there. Which interface? Router 2 interface. Interface area 0 by 1 by 0. IP RIP is not there. IP recipe of NAT split horizon. So RIP is not there. The command should be IP RIP authentication. I remember it should be configured only on the interface. RIP authentication. From the system sample version. Always you need to upload, yeah, you have to read the docs. There are 2 router 1, router 2. Here are something. Tomorrow we learn subnetting. At the time. Yeah, you see, you go to configuration mode, keychain 1, key 1, key 1, key string. In interface do that. Interface we don't create the authentication, no. But the serial you see on the serial IP address, IP RIP authentication, yeah. So on the interfaces we define the authentications. Enables authentication on the interface and configure the keychain and that will be used. The command should be IP or IP authentication. Also in the router 2 also should be having the key chain can be different name, but the key 2, that's what the key 1, and the key string should be matching. Key 1 and the key string should be matching. This is called plain text authentication. And also there is another type of authentication called MD5. MD5 is more secure than that. So to configure MD5, I can keep keychain, key string, password, and again IP or IP authentication mode MD5. The command to do MD5 authentication. Also there is a so debugging IP or IP. You can see the plain text authentication. Text authentication password can be seen. Okay. The MD5 authentication will be encrypted. So if it's been encrypted, you cannot decrypt and break the password. So that's why we use MD5 authentication. Specifically, we teach these documents, these things in the CCNP level, but you can prepare once you have a, once you have a push on the protocol, you have to mug up, you have to learn the things. But you take this peek of this, our today's lab. But when you do the authentication on the router 1 and router 2, on both sides, on both serials, you have to configure. And later onwards, later classes, I will try to give you whether GNS are in the GNS3 or I will give the E setup. At that time, you can do more practice on that. Okay, Abdul?
Sure, Chandu. Sure.
Because packet tracer does not support all.
Yeah, you told me before, like we'll start GNS, the simulation software
Then
later on.
GNS,
Yeah.
another one is Cisco packet tracer.
Okay. Yeah, GNS3 I have already in my system.
The GNS you can do it, it will work.
Oh, okay. Okay.
Bro, these are so good.
One question, Chandu. If I do the dumps right now, also I can appear for CCNA exam.
No, you should remember, you should have the English.
Pardon?
If you know the English,
Mm-hmm.
and you have to read the questions and answer,
Mm-hmm.
and thus we can test the exam and do the part. I'll give you in the next tomorrow class, okay?
Okay, okay. And for registration, how much is the cost right now, current?
For CCNA exam,
Yeah.
I think always they'll have 325 USD.
Oh, 325 US dollars?
Yes.
Okay. Okay.
325 USD will be there.
And how many attempts they'll give?
They'll give one attempt only. But if you prepare the question,
Mm-hmm.
you can prepare the questions in 3 weeks, and the next week you can do the exam.
Oh, okay. So like only one attempt?
One attempt only. But second attempt, they give some discount.
Oh, wow.
Yeah, they do
Oh.
business.
No, 3 attempts. Okay.
What discount? Everybody, they do this thing.
Okay. Because I have seen some websites, Spotify, some websites, they are saying guarantee. What is that? I don't know.
No, they tell all that, because there are some Microsoft resellers are there. We should go to the Microsoft resellers dumps only. I'll give the dump name, even the domain name also. We'll buy that by paying some $19 like that.
Okay.
And you can prepare. There are so many 400 questions will be there.
Okay.
You have to prepare all of them, and you can clear the. I made some students from Denver, even CCNP also.
Wow.
In the lockdown, they sit in the home. They do the exam in the home. Time no testing centers.
In first attempt only they cleared after the dumps?
Yes.
Yeah. So directly, you don't advise me directly to CCNP or directly CCNA?
You see, if you study CCNP, don't do CCNA exam.
Yeah, I watched this.
If you
No,
get
like
the
your class and dumps for CCNP will help me clear
No, no.
CCNP, you think?
No.
No?
our classes, firewall zone classes, firewall institute, what they ask me to teach, I'm teaching.
Okay.
Yeah, that's no problem because they give me the duration of 1 month. I try to cover up maximum. I can spend even some time also. But CCNP is little harder, sir.
Okay.
You know, in CCNP we need to study a lot about the protocols.
Okay, because I am interested after clearing this CCNP, I want to clear PC and SC also, the Palo Alto. That also you teach, right?
Yeah. Yes, I have a class. 2 classes.
So that is how many weeks that is?
Actually PCNSC we take 1 month class, and dumps for PCNSC is little harder.
Oh, okay.
What it will tell some students is take the help and do the exam. So
Oh,
means
okay.
we get the dumps directly from Palo Alto, and from testing centers actually they help us to do the exam.
Because by year end, I need to have PC and SC also.
If you want to do PCNSC tomorrow, you can do it, no problem. But I suggest students to have technology. You know, without technology, if you do certification, it's not good.
Okay, again, it's
For-
volatile, it will get out, right? Yeah.
Take the classes, and then end of the month, end of the course, be certified. Then what the notes that I give you can prepare technically, and if you can attempt for the interview for the purpose.
Okay. Okay.
Okay, then we'll see tomorrow, Pranay. Okay,
Okay. Thank you.
and also we'll see
Okay, sir.
tomorrow at sharp 8 o'clock.
Okay, sir. Bye.
Thank you. Thanks
So
for
let
your
them
time, Chandu. Yeah.